Okay, so this whole paragraph, and you don't have to write the whole thing, is talking about there are a limited number of possible rational roots or rational solutions to this polynomial when x or that's set equal to 0. And the way that we find all of the possible rational solutions is we take the factors of the constant term, okay, and then we divide that by the factors of the leading coefficient. Thank you. So the factors of the constant term, that's the term in this polynomial that does not have a variable with it. And we divide it by the factors of the leading coefficient. That's the coefficient in front of the highest degreed term. Okay, so the highlighted part is what we really need to know. That's what we're going to be doing. And when we are given our polynomial equations, they should be in standard form so that our leading coefficient is listed first. The constant term should be listed last. So here's what we do. Okay, let's first of all, what are the factors of my leading coefficient? The 2 right here. What are the only numbers that multiply to give you 2? 1 and 2, right? Then we want to list the factors of our constant term, not the sign with it, just the number. What are my factors of 9? I can do 1 and 9, and what else? And 3. But 3 we don't have to do twice, right? Okay, so the factors of 9 are 1, 3, and 9. Is everybody ready to kind of watch what we do? I'm going to try to use the highlighter to help, but so I'm going to take the factors of my constant term, starting with the first one, and I'm going to divide it by the factor of my leading coefficient. And they can be either positive or negative. So when we do this, what is 1 over 1, or 1 divided by 1 give you? 1. So my first set of possible rational solutions is 1, plus or minus 1. Okay, because they can be positive or negative, we put plus or minus in front of everything. Then I do the same thing, but I use this 1 and I do it over the other factor of 2. So it would be plus or minus 1 over 2 is just 1/2. Okay. So I use this 1, I put it over that 1 first, and then I put it over that 2 first, or second. So far, so good? Okay. Do I have more factors of 9 that I haven't used yet in my list? Yes. So then I go to the 3, and I'm going to repeat the process with the 3. It's going to be plus or minus 3 over 1, which is just 3. And then we're going to do plus or minus 3 over 2, which we just leave as a fraction, 3/2. So I used the first factor of 9, which was 1, and I did it over both of the factors of 2. Then I used the second factor of 9, and I did it over both the factors of 2. Now what I'm going to do is I'm going to use the third factor, which is actually 9, and I'm going to do the same thing. I'm going to repeat the process. We're going to take plus or minus 9 over 1, which is just plus or minus 9. And then we're going to do the same thing, and we're going to go 9 over 2, plus or minus 9/2. So those are all of the possible rational solutions to that polynomial equation. That doesn't mean that they are all solutions. They might not have any of them as solutions, but they are all possible rational solutions. And then when we tie this all together next week, we'll take those, we'll use synthetic division until we find one that actually is a solution, and we can go from there to solve. Okay, but again, we'll talk more about that on Monday. Everybody kind of okay with that? Do y'all remember doing this before, I hope? Yeah, okay. All right, so we're going to do the same thing. It says list all of the possible rational roots. We're not solving them. We're not finding what the answers are, but we are listing all of the possible rational solutions. So I'm going to do number 2 with you, and then I'm going to let you try 3 and 4. So my polynomial equation is 3x to the third plus 9x minus 6. We're going to start by listing the factors of our leading coefficient. Factors of 3 are just 1 and 3. And then my factors of 6 are 1, 2, 3, and 6. Everybody ready? Okay, again, we're starting with the factors of the constant term. So 1, 2, 3, and 6. Each one is going to be divided by the factors of the leading coefficient, which is 1 and 3. So we always put our plus and minus in front. We're going to start with a 1. So plus or minus 1 over 1, which is just 1. And then we're going to use that 1 with the 6 again, and we're going to put it over 3. So plus or minus 1 over 3. Now I've used the 1 that's a factor of 6 with both of the terms that are factors of 3. So now I move on to the next one, the 2. So it's going to be plus or minus 2 over 1, which is 2. And then plus or minus 2 over 3, which I cannot simplify. Okay, so we've used the 1 on the factors of 6. We've used the 2 as factors of 6. Now we're going to do the same thing with the 3. We are going to go plus or minus 3 over 1, which is 3. And then if I do plus or minus 3 over 3, what does that actually reduce to be? 1. And I already have that listed, don't I? So sometimes you'll get multiple answers or multiple of the same possible roots. You don't need to list them more than once. So since 3 over 3 reduces to be 1, and I already have that in my list, I don't need to list it again. And so then we'll move on to the 6. So we're going to do plus or minus 6 over 1, which is just 6. And then if I do plus or minus 6 over 3, what does that reduce to be? 2, and I already have 2 in my list as well, right? So I don't need to write it again. So here are all of the possible rational solutions for question number 2. All right, I would like for you to try number 3. All right, so with question 3, I'm going to start by listing the factors of my leading coefficient. That's 6. So that would be 1 and 6 and 2 and 3. And then for 18, let's see, I got 1 and 18. I got 2 and 9 and 3 and 6, right? So I got a few more factors here. What is always one of our possible rational solution sets? Plus or minus what? 1. Plus or minus 1 is in every one because everyone has the factor of 1. So that is going to be 1. So I'm going to start, okay, plus or minus 1 over 1, which is 1. Plus or minus 1 over 2, which is 1/2. Plus or minus 1 over 3. And plus or minus 1 over 6. That's just using that first one, right? So we're going to have quite a few here. Then we move on to the 2. So it's going to be plus or minus 2 over 1. If I do 2 over 2, that turns to 1, which I already have. And then plus or minus 2 over 3. And then if I do 2 over 6, what does 2 over 6 reduce to be? 1/3, right? Which I already have that as well, so I don't need to list it either. So I'm finished with the 2's now. Then I move on to the 3. So let's see, we're going to go plus or minus 3 over 1, which is just 3. Plus or minus 3 over 2, which I don't have. 3 over 3 turns to 1, which I already have. And 3 over 6 turns to 1/2, which I also already have. So then I can move on to the next set. Doing my 6 now, plus or minus 6 over 1, which is 6. What does 6 over 2 turn into? 6 divided by 2 is 3. That's already listed. And 6 over 3 turns to 2, which I already have. And 6 over 6 turns to 1, which I already have. So the only one I could list off of that 6 factor is plus or minus 6. All right, then we'll go to the 9. So we're going to do plus or minus 9 over 1. Then plus or minus 9 over 2, which doesn't reduce and I don't have. 9 over 3 reduces to be 3, which I have. And 9 over 6 reduces to be 3 over 2, which I also already have. And so then I move back to the 18, okay? So we're going to go plus or minus 18 over 1, which is 18. 18 over 2 is 9, which we already have. 18 over 3 is 6, which we already have. And 18 over 6 is 3, which we already have. So that is the complete list of all of my possible rational solutions. So do you see how when you have more factors, it gets a little bit longer? Okay. Still, factors of the constant term divided by over, if you don't want to think about it as division, writing them as fractions over the factors of the constant term. And then for number 4, my factors of 8 are 1 and 8 and 2 and 4. But with my constant term, I only have one factor, right? So that's going to make it a little easier. So we'll do plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4, and plus or minus 1 over 8. I don't have any other factors for my constant term, so therefore that is going to be all that we have. So again, this will be brought together when we start working next week on how to solve these polynomial equations. We are going to use this rational root theorem to help us hopefully find some solutions easier than we could trying to do it any other method. Do I have any questions so far? All right, the next thing we're going to talk about is what we call the conjugate root theorem. Do you guys remember what conjugates are? Like x plus 3 and x minus 3. They're exactly the same, but the signs are different. So for the conjugate root theorem, here's the important piece. If a polynomial has a root with either I or with a square root, then it must also have its conjugate as a solution. Okay, you don't have to write that next sentence. If a polynomial has a solution that has an I in it, so any imaginary solution, or a square root, then its conjugate answer, technically its opposite, is going to also have to be a solution. And what they're going to do is they're going to give you an answer and they're going to say find the other roots. Well, you're just looking at the ones that they give you. If it has an imaginary in it or it has a square root in it, then you are going to give the opposite of that, its conjugate, also as a solution. Okay, you don't have to write that second sentence where it says a polynomial function p of x with rational coefficients has the given roots. We're finding 2 additional roots is what we're doing. Your directions will say find additional roots. For number 5, it's telling me that I have 2 solutions. I have negative 2i and I have a positive square root of 10. Both of those, one involves an imaginary, one involves a radical. So for both of them, they are going to have its opposite or its conjugate solution as an answer. So if we focus on that first one, the 2i, it's negative, correct? What's the opposite of negative 2i? Positive 2i. So that means positive 2i also has to be a solution. How do I know that? Because I looked at the solution they gave me. It was a negative 2i. Its opposite, which would make it a conjugate, also has to be a solution. And then the other answer is the square root of 10. Okay, that has a square root in it, so its opposite is also going to be a solution. So if I have a positive square root of 10, what's the opposite of that? A negative square root of 10. Okay, so those are my 2 other roots. I don't even know what the equation is, but I know that those are 2 other roots because of the first 2 roots that they gave me. If it's not imaginary and if it's not a radical, then it doesn't require the opposite as a solution. Go ahead and try 6. You have 2 solutions. You have I, and then you have 7 plus 8i. Okay, think about what the conjugate is for 7 plus 8i. Conjugate for I would be a solution, and then the conjugate for 7 plus 8i would also be a solution. So if I is a solution, what would the other solution be that matches it? Negative I. And if 7 plus 8i is the solution, what is the conjugate of that? 7 minus 8i. So those would be my other 2 solutions based off of the 2 that they gave me. Okay, so that's what the conjugate root theorem is. If it gives you a solution that has an imaginary or a radical in it, square root, then its conjugate or opposite is going to also be a solution. Anybody have any questions there? All right, I'm going to skip the next two examples because they're just the writing the equations that we just did the other day. And what I mean by that is if I give you the roots of 3 and 4, write the equation. We just did that. We don't need to do that again, right? Okay. So what we are going to do is we're going to think about the conjugate root theorem. It is telling me to write a polynomial function with rational coefficients so that p of x equals 0 has the given roots. Okay, p of x equals 0 just represents your polynomial function. That's just how they say that in symbols. But what we are going to do is we are going to write an equation, okay, with rational coefficients so that the function has the given roots. So with number 9, my given root is negative 3 square roots of 2. Based off the conjugate root theorem, what else is going to be a solution? A positive 3 square roots of 2, right? Just like we just did on the previous two questions. All right, then we're going to treat it exactly the same way we did on the quiz when we were writing the equations. Set each one equal to x first. Then we take those and we move those over with the x so that we have binomials equal to 0. So I'm going to add my 3 square roots of 2 here over with that x. And on this side, I'm going to subtract my 3 square roots of 2 over with that x. Is everybody okay with that so far? Okay. Exactly like we did before, except for this time they only gave me one solution, so I have to remember that conjugate root theorem and say, okay, well, it's positive 3 square roots of 2 is also a solution. Set them equal to x, turn them into binomials. Then after that, we take those binomials and we put them in parentheses so that we can multiply them out, just like we did with the regular numbers a few days ago. And then we FOIL. We have 2 binomials that we need to multiply, so we are going to FOIL those together. Starting with the x's, x times x is x squared. If I'm multiplying x times a negative 3 square roots of 2, I'm going to write it as a negative 3x square roots of 2. I like my x to be in front of the radical instead of behind it. If you put it behind it, it's not wrong, okay? That's just the way I like to write it. Then I'm going to multiply a positive 3 square roots of 2 times x, so that's going to give me a positive 3x square roots of 2. And then here's where the tricky part comes. If I multiply a positive 3 square roots of 2 times a negative 3 square roots of 2, that's going to give me a negative 9 square root of 4. Everybody okay with that? All right, and then we're going to combine our terms. What happens to those middle terms when I multiply conjugates? They always what? Cancel. So I've got negative 9 times the square root of 4, but what is the square root of 4? 2. So it's really negative 9 times 2, so it's going to be x squared minus 18 equals 0. Okay, again, put it equal to 0 or equal to y. Either one is okay. Now, I just want to show you this. Bring that over here and let's just, you don't have to write this down, but if I had x squared minus 18, think about how we used to solve it. We would say, all right, let's add our 18 over. We'd get x squared equals 18, and then we would have to take the square root, right? And anytime you take the square root, the first thing we put is plus or minus. And then if I simplify the square root of 18, that breaks down into 9 times 2. And what is the square root of 9? 3. So do you see how I got the roots that we started with up there? By just taking it and solving it? Not that you have to do that. I was just kind of proving to you that it works. Make sense? All right, I want you to try these last two. Again, if it has an I in it or a square root in it. If 5i is a solution, what else is a solution? Negative 5i. We're going to set each one equal to x. We're going to turn them into binomials by moving that I over with the x. Then we take those 2 binomials, we put them in parentheses to be multiplied together. That's x squared plus 5ix minus 5ix. And when I multiply negative 5I times positive 5I, I get a negative 25 what? I squared. And what does I squared do? It turns it to a, what kind of 25? Positive, right? And I squared equals negative 1. So that's like saying negative 25 times negative 1, which would give me a positive 25. Those middle terms cancel as they should when we multiply a pair of conjugates. And so my answer is going to be x squared plus 25 equals 0 or equals y. With 11, if negative 3i is the solution, what else is the solution? Positive 3i. And again, we're going to do exactly the same thing. Set them equal to x. Turn them into binomials by moving them over with the x's. Put them in parentheses next to each other to be multiplied out. And then we FOIL. That's x squared minus 3ix plus 3ix. And that's going to give me a negative 9i squared. Middle terms cancel again. And that I squared turns that negative 9 into a positive 9. So we get x squared plus 9 equals 0 or y equals x squared plus 9.